Okay, today we're looking at Uber drivers' stats. We're doing a bit of simple data analysis. Not too complex, it's not too hard to do. Okay, we'll look at the notebook. We load the tidyverse and read are we reading the data? We have the data, and let's see, that is the data. Fares, kilometres and minutes. It is data from 2018 from about July till about September. It's 503 trips, I think. Randomly selected. Yeah, we'll move on. We are there. We've got the Uber stats. We're putting it into another data frame called Uber analysis. We do a box plot, and we're doing a ggplot, box plots, one box plot of fares. Okay, now here's the standard box plots. As you can see, the bulk of the fares and the median's around $18, which is was pretty accurate at the time for a year or two. Probably 3 years that I did it part-time, they were accurate. Mostly short trips. The amount of kilometres was, it was about, probably about 10 kilometres was the average. And they were generally around there, around the 15 kilometre, 10 kilometre mark. The average fares were around $18 to $20 mark. There was a bit of outliers there around the $60 mark. That was a good day when you got a few of those. The kilometres were, mostly that's from about 30 to about 40 kilometres. You didn't get a lot of those. You can see there's a few outliers. And then there was the extreme one, which took an hour. Kilometres, which took 60 kilometres, yeah. They were 30 to 40 kilometre trips, yeah. And in the minutes, depending on the traffic, it varied, but it was generally bunched between about 50 to 65 minutes for the outliers. Normal time for the trips were about 20 minutes, between 15 and 25 minutes. I think I was calling that minutes, that should be kilometres. Yeah, the average trip was 10 to 15 kilometres. The average time was 15 to about 23 minutes. And there was an outlier, and there was one extreme trip which was a long way. It was about 55 kilometres. It took 100 minutes, bad traffic. Not quite 100 minutes, I think it was roughly about 95. Let's move on. We're doing a simple linear regression on fares versus kilometres. The x variable is fares, the y variable is kilometres. We use Stargazer library because it presents a nice fit of the data. And we're doing a ggplot with a low S best fit line through it of the data. Now we'll look at the results. Kilometres, you made about $1.76 per kilometre, which was pretty close to Uber's estimate. Uber estimated, I think you made $2, something like that per kilometre. And I'm not sure what their cancelled trips, I think they claim you made about $3 or $4. So it was very similar to what they estimated. So basically the intercept was really what you got if someone cancelled on a trip, which was about roughly $4. And for each, or from the start of the trip, for each kilometre after the start, you made about $1.76. And you can see it's a good fit. 0.9 R squared, adjusted R squared similar. Degrees of fit, the F statistic degrees of fit, 3 stars, which means it's at the 99% interval. And anyway, we'll look at the chart, the best fit. And you can see the data fits fares versus kilometres. It's a pretty good straight line fit. Scatters all around, mostly around the less than 20, less than 50 kilometre range. And then the outliers and the extreme outliers. $100. That was about 60 kilometres, 55 kilometres or something, 60 kilometres. And we'll do the same thing with minutes, time. And we got minutes. It took about a minute. You made 95 cents a minute approximately. And the constant or the pickup fee was about $1.33 per minute. That's instead of working out the rate per kilometres, we're working out the rates per minute. So yeah, it doesn't pay very well to be an Uber driver. It didn't pay then, and I don't think it'd be much better now. This was 3 years ago. I don't think much has changed since then. It's probably even worse now, considering inflation and so forth. Once again, it was a good fit, 99 degrees, 90% confidence, 99% confidence interval. The R squared's not as good there, 782, 781, 530 observations. Where's the chart? Is that fares kilometres? Should be one for time. Oh, here's the chart for time. And yeah, there's a chart for time. It's not quite as good a fit. You can see the scatter on time is a bit more dispersed. You can see it goes up there and the outlier is out here. Maybe it would have been better fitting an exponential curve or quadratic curve or something. Get a better R squared, a linear manipulation of a non-linear curve, not a maximum likelihood method version. So I can still get the statistics. But yeah, it's still pretty close. I didn't bother doing much more analysis. You could go deeper into it if you're really concerned. Anyway, I'll put this notebook on pubs for anyone that's interested. For actually downloading the data, I don't know if you'll be able to. Not sure how I'll have to put the data somewhere. Anyway, thanks, bye.